Okay, so this is a simple kinetic molecular model. Brownian motion, what is it? Well, if you have an experiment where you have a microscope and under the microscope you have a slide. Okay, you shine bright light through it. And on that slide you have a little cell, and inside that cell you have smoke particles and air. Now what you see when you look into this cell, you see specks of light moving around in a random motion. This could also be done with carbon and water. Could also be done with pollen, as Mr. Brown did originally, it was named after. So what are the observations? So we have specks of light the smoke particles are too small to see, so we see the specks of light of the smoke particles. They are moving in a random motion. Now, very important is you cannot see air. Okay. Now, why is this actually happening? Well, it's actually because of invisible, fast-moving molecules smacking into the particle. Okay, it's just running into it. So imagine sort of a ball in the middle of a dodgems field. Okay, all these dodgems running around, hitting this ball, and the ball will fly off. And then another dodgem will come in, hit it, and it'll fly off a different direction. So it's getting hit by fast-moving objects. Now, because these objects are so small, you can't see them. And that means for these small, invisible objects to be moving something that is visible under light, okay, as a bright light, as a speck of light, then they must moving very fast. Sort of like a bicycle moving a truck. So the bicycle needs to be going very fast to be able to move the truck when it collides with it. So what's the conclusion? Well, all fluids have fast moving particles in them. Okay, so it's evidence for that. Evidence for moving particles. And that's where kinetic come from, because it's kinetic energy. Now, because of this, you can explain things to do with solids, liquids and gases. Whenever we heat something, we provide it with energy, the object. And it always goes to kinetic energy in most cases. Sometimes it can go to potential energy as well, to change the state of the object, the molecules. So, one thing we'll look at later, one important statement, kinetic energy is associated with temp, potential energy is associated with state. In other words, solid, liquid or gas. Now solids, they have a fixed regular shape. Liquids take the shape of the container, but they don't spread out through the container. They don't fill up a container completely. However, gases do. And you could even have, say they have no fixed shape or no shape. Solids, the molecules vibrate in position. Liquids, they vibrate but also have enough kinetic energy to change bonds. They don't remove the bonds, they just change them. Gases, fast moving, and there's no bonds. Something I mentioned before, so as we increase temperature of liquid, solid or gas, the vibration of the motion or motion of the molecules increases. So if we had a solid, here's my lattice in a solid. So the molecules or atoms are all nice and tightly bound. These vibrate on the spot. Now when you heat the thing up, so we provide heat, then they start vibrating more. If they vibrate enough, then things can change. In other words, you could turn to liquid or to gas. So if you had a gas, then you heat it, the kinetic energy will increase, so it must go faster. So, particularly important is temperature changes the kinetic energy of the molecules.